All right, this is Matgen110. We're looking at review for chapter 7 and 8 test. So let's jump in. The first one, they want to know the domain. Domain is a list of anything that x can be. So there's only one number that x cannot be. It cannot be -7. So x is not equal to -7. That's the domain. It's basically the domain restriction is you're giving me. So you could say all real numbers. If you wanted to write out all real numbers except -7, you could do it that. But for shorthand, you can just say x can't be equal to -7 because that's what gets 0 on the bottom. We don't care about the top. The top could be 0 all day. So this is what we can't have. Can't have the bottom equal to 0. You can just subtract 7. And there we are. All right. Reduce. Or you think it says simplify, same thing. So we divide top and bottom by 4 to reduce the 4/16. That's 1/4. And then there's 1 m on top, there's 4 m's on bottom. They cancel 1 for 1. There's 3 m's left on the bottom. And then m-6 just stays. m-6. And that's it. All right. This one, easy peasy. This one's the easiest one on the test. It's already factored, and everything's, that binomial is being multiplied by that binomial, so you just cancel the binomials that are exactly the same, and you're done. That's it. It's just x minus 3 over x plus 5. Done. Don't do anything silly like try to cancel an x that's being added or subtracted. You don't get to cancel things that aren't being multiplied. All right? This one is maybe one of the hardest ones on the test. For 2 reasons. 1, we have to factor, which, that's going back. And 2, you have to remember to distribute this negative throughout the top. That has to hit that and that. So on the top, we're going to have x squared minus 10x plus 25 all over x minus 5. Because they do have a common denominator. That's the good news. Now we have to factor. So you think about things that multiply to be 25. But that add up to be a negative, so it's got to be negative. And there's only 2 suspects, and that's who done it. X minus 5 over x minus 5. And so now, after you distribute the negative, factor the numerator, you can cancel. Now it's like number 3. So we can cancel those x minus 5s away. And we're just left with x minus 5. Again, if you want to keep the parentheses on it, you can, or if you want to drop them, either way. All right? This one is already all factored. It looks really bad. It's not that bad. It's already all factored. It's a divide by, though, so we never divide fractions. We multiply by the reciprocal. So we take that times, and now the numerator becomes the denominator, and the denominator becomes the numerator. And now we're right back to this problem again. You're just canceling things that are the same. The x minus 3s, the x plus 3s, the x minus 4s. That question comes up. They're like, can we cancel them when they're on the same one? Absolutely you can. So now look, we got 2. Oh, we could do the 2 into the 10. Divide by 2. Divide by 2. So that becomes a 5. That becomes a 1. So everything canceled off at the top, so that's a 1 up there. And we got a 5 and an x plus 4 on the bottom. And that's it. You're done. 1 over 5 times quantity x plus 4. If you want to make it 5x plus 20, you can, but you don't have to. You can just leave it factored. That's fine. All right. This one, again, it looks worse than it is. 7 over 3y divided by, that big long divide by sign means divide by 14 over y squared. And now it's just like this problem, only a little less complicated. 7 over 3y times y squared over 14. Top times top, bottom times bottom, and reduce. So 7y squared over, oh, let's kill that 7 into the 14 twice. So 6y, and now we got y squared on top and y on the bottom, so one of those y's dies. So we're looking at 7 y over 6. All right. Oh, not 7. Whoa, whoa, whoa. Back it up there. That 7 went into there. 1. See, I should have multiplied first and then reduced. See what happens. That should have been 1. That's a 1. A 1y, or just y over 6. Because we divided by 7, both top and bottom. That became a 2. 2 times 3 was 6. That's just a 1. 1 times y, because the y's canceled. All right. Okay. So be careful. I didn't have the room. I should have rewrote that one. It's easy to write down the thing that you already canceled off. Okay, let's, I got the rag in my hand. Let's do the next page. So number 7, we got m plus 2 over 8 equals m over 3. So you're just going to cross multiply and solve. So you got 3 times m plus 2 equals 8 times m. So do the distributive property. 3m plus 6 equals 8m. And now we want to red row over the m's over. Get all the variables to one side. That's isolate the variable, right? So 6 is equal to 5m, and then we divide by whatever number is in front of the variable. So divide both sides by 5. M is equal to 6/5. And we're done with that one. Let's look at number 8. Ooh, number 8 looks worse than it is. It's not all that bad. We got 1 over x plus 5 plus 1 over x minus 5 equals 1 over. So look, we find the LCD. It's an equation. Equations mean we don't have to play with fractions if we don't want to. And we don't want to. So the LCD is this times this. Because look, that's both of them. So the LCD is x plus 5, x minus 5. I know that's a little abstract. Now what you're going to do is multiply the top of everything by x plus 5, x minus 5. And check out what happens. So look, the x plus 5's cancel. So you have 1 times x minus 5 plus x minus 5's cancel. So you got 1 times x plus 5 equals 1. Do the distributive property, but it's times 1, so it's just 1x minus 5 plus 1x plus 5 is 1. Like terms, so we get 2x. And then plus 5 minus 5 wipe each other out. It's just equal to 1. And then we divide both sides by 2. And x is equal to 1/2. All right. Let's look at number 9. When you've got two things working on the same job at different rates, you set them up as fractions. It becomes a fractional equation. So look, 1/12 plus 1/6 is equal to 1 over x, or t if you want it for time. So the one computer can do the job in 12 hours. The other computer can do the job in 6 hours. If they work together, how quick can they do it? Well, we don't know, but I do know it's less than 6, because the one can do it by itself by 6. The slower one is helping it, so it's got to be less than 6. So we're going to do the same thing we did there. LCD between 12 and 6 and x is 12x. Don't forget the x. That's the most common mistake I've seen throughout my 31 years of teaching algebra, is students forget the variable all the time. All right, so now look at what happens here. The 12s cancel. We got 1x. Plus the 6 cancels into the 12. We got 2x. Equals the x's cancel. We got 12. And this is a pretty easy equation. Now, 3x equals 12. After we combine the like terms, you divide out the coefficient, and x is equal to 4. And that is less than 6, 4 hours. So 4 hours time for that one computer to do the job, or for both of them to work together. Square root of 49/81, the square root of z to the 18th. So look, this one is the square root of 49 over the square root of 81. So that is 7/9, and you're done. This one, when you take the square root, there's a 2 there, even though we never write it there. And so you divide whatever the index is into that number. So that's just z to the 9th. And then ditch the square root sign. Don't put the square root sign back on there. Lots of students leave that square root sign. All right. Let's continue. In the past, students have done really well on the radical ones, the square root ones. So that's why I wanted to keep this test on the books with the online stuff. All right, so let's take a look. Number 12 is the square root of 72. And 13 is the square root of x cubed y 7th. And 14 is the square root of 48x to the 5th. Okay, so look, I'll show you 2 ways to do this. There is a quick way. You do perfects and leftovers. That's the square root of 36 is perfect. Square root of 2 is the leftovers, meaning 36 times 2 is 72. Now you can't just do anything that you want and say, oh, like 12 times 6, you wouldn't want to do, because 12 is not perfect and 6 isn't perfect. One of them has to be a perfect square. So you want the biggest perfect square that goes into there. The biggest one is 36. This is just 6 square roots of 2, and you're done. That's called simplest radical form, SRF. All right? There's another way to do it, though. Some students hate this way. They're like, oh, I can never think of the right perfect square, and that's fine. There's another way to do it. You take 72 and you break it down into its prime factorization. So what do you think of with 72? You think of 9 and 8? And then 3 times 3, so those are prime. And 2 times 4, 2 is prime. 4 can go again, 2 times 2. So like the little factoring tree, remember that? And you write it as that. And it's prime factorization. 2 times 2 times 2 is 3 times 3. And now you need groups of 2, whatever the index is. That's the group that you need to get out of this like prison. Think of it as a prison. And then only 1 lives though. And then that one is stuck. And 6 square roots of 2. So that's a different way of doing it. Either way, I don't care which way you do it, and just so you get it right. And so either way, if you want to do it this way, I've had a lot of students like that way. I've had a lot of students like that way, because this way is efficient. That way it's not as fast, but it's maybe easier to get it right. These, most everybody doesn't break it down into primes. They just say, okay, look, perfects, when it's a square root, is an even power. So you just bump it down to the next even. If it's not even already, you bump it down to the next even power. And then in the leftover bin, it's always just going to be x to the first and y to the first. And now remember, we divide by 2. So that's x to the first, y to the third, square roots of xy. And that's our answer. All right, this one is kind of a hodgepodge between both of those. So again, if we go perfects and leftovers, we got 16x4. In the leftover bin, we got 3x. And so then you evaluate the square root of 16x to the 4th. That is 4x squared. and square roots of 3x. So that's how you do that one. If that threw you, you could break this one down. That's fine. We could do, what is that, 6 times 8? So 2 times 2 times 2 times 2 times 3, right? That's 8 times 6. And then 1, 2, 3, 4, 5 x's. And now you need groups of 2 to get out of prison, but only 1 lives. Groups of 2, only 1 lives. Stuck. Groups of 2, only 1 lives. Groups of 2, only 1 lives. Stuck. And so there's your square root of 3x. And multiply that back in 4x squared, square roots of 3x. All right. So 2 different ways to do it, because 16 wasn't very obvious. It wasn't like most people look at 48 and go, oh, I know, 16 times 3. All right. Let's do the last page of the review. So we got 15 is the square root of 2/50. So you reduce that inside, it's still under a square root, 1/25. And now you do the square root of 1 over the square root of 25. It's 1/5. Be careful. Lots of people got that one wrong last year because they just went, reduced it to 1/25 and wrote 1/25. They completely forgot about the square root. So make sure not to do that. 2t7 over 2t. So we reduce these. The 2 goes into the 32 16 times. The t's cancel. There's t to the 6th. But now remember, it's under a square root. And this was really convenient because when we reduced it, it reduced into a perfect square and a perfect square. So we just have to evaluate that. That's 4 t to the 3rd, and we're done. All right, let's do the last 4. 17 is 5 square roots of 6 minus 4 square roots of 6 plus 3 square roots of 2. So remember how this works. Like terms can be combined. 5 minus 4 is 1, but we don't put the 1 there ever, so that's the square root of 6 plus 3 square roots of 2. That's it. You can't add those up. You can't break down the square root of 6. It's just, that's it. 2 terms. All right. 18. I don't like 18. I wish it wasn't on here, but it is. So be careful on this one. There's going to be one like this on the test. When you break it down, perfects and leftovers. Square root of 9, square root of 6, plus square root of 4, and the leftover there is square root of 5. So you can simplify it, but you can't combine them. It's 3 square roots of 6 plus 2 square roots of 5, and we can't do anything with it. That's it. They're unlike terms. And so it just stays like that. And there is one like that on the test. 19, 6 square roots of 12 minus the square root of 75. This one is a little better. 6, you get 4, and then the leftover is 3, and you get 25, and the leftover is 3. And so now look, we got 6 times 2 times the square root of 3 minus 5 times the square root of 3. So that is 12 square roots of 3 minus 5 square roots of 3, which is equal to, what, 7 square roots of 3. All right. And then the last one here, let's squeeze the last one over here. Number 20 is 3 square roots of 6 minus 7 square roots of 6 plus the square root of 24. So we can do the first 2 right away. We can combine those. That's negative 4 square roots of 6. And then this we got to still break down. So perfects and leftovers. And negative 4 square roots of 6 plus 2 square roots of 6. And now we can combine those like terms. So -2 square root of 6. And that's it. So those 20 problems are going to be on the test. Study, study, study. Make sure you don't go into the test cold, meaning that you've actually worked through at least a blank review before you start. All right.